when we look at the remote applications, these are in order of importance what we're looking at when we test. And so a lot of the remote capabilities are auxiliary functions. They're not required, unlike the telesurgery where the link is in critical path. Some of the servicing and mentoring aspects aren't in, the network's not in critical path, so they're auxiliary type of capabilities. And so we really look at it all the way from design in isolating that functionality onto separate hardware, into separate software processes, so that we can, isolate the exposure for any sort of issue that may occur, so that the rest of the system can operate and drive the robots, and all the control systems that are on there can function in a different space. So that's really our primary mode. When we go in and test, we need to confirm that. And so that's one of the things with CodenomiCON's products and the fuzzing. We started to integrate that into our testing platform and methodology, so that we can really look at it and use that type of technology to start addressing that question even more for the network-based capabilities. And then when we get down there, obviously we're building in these capabilities for a reason. And so we wanted to be reliable and robust. But we do have very stringent checks inside of the embedded system, especially for some of the network communication, where if it doesn't understand what's going on or receives a packet that it doesn't recognize, if that occurs, then it will just shut down its network communication, not communicate out any longer until the system goes into a different state. And so ours is patient safety, making sure it doesn't impact the system, but then clearly we want to focus on having uptime associated with with our applications that we have built in there. So just a quick overview of how we got into to realizing that fuzzing was something that we needed to bring into our into our testing scheme. We had our systems in our remote servicing application where we were just finding that they would just drop off the grid, and so they typically communicate up at some periodic duration, and we were just noticing that some of them weren't communicating, and the way that it was being resolved is we'd get one of our field engineers, they'd go and they would just power cycle the system and it'd start working. And so we were trying to understand what that was, and so to address that uptime and trying to make sure that those systems were online, so our customer support team had the benefit of the servicing capability. We found CodenomiCON, we brought in their test suites, and what we found was that when we used the DNS server suite and we had our system as the DNS client, we were able to go through all the different variations of DNS responses, and we found that there was a certain signature and a certain class of responses that the client, DNS client, was unable to parse. And so then our safety systems kicked in and said, oh, I don't understand this, and then the system would just stop communicating. And so one thing that I forgot to mention was that in our systems we've got our embedded implementation, and since we have a real-time requirements, we try to minimize the footprint of the majority of the software modules. And so with this, a lot of the parsers and whatnot that are done are very small footprints, and so they're not the full-blown implementation. And so we found that as we've started using these tools, we've been able to learn exactly what they're good at and what things they're not able to handle very well. And so what it allowed us to do was very quickly. Took a little bit of time because our system only checked in, I think, every 10 or 20 seconds, and so took a little bit of time to go through that whole DNS suite when we had to do our DNS requests. But we were able to find that signature. We were able to dig into the software and figure out why it wasn't able to handle that and ultimately fix it. And so with that, I was pretty much sold that fuzzing was something we needed to integrate into our into our everyday stuff. And so that's kind of the path that we're on right now.